Okay, voiceover for our first homework assignment. Using common sense. All right, so these first three problems weren't even addressed. We started out with talking about data. Um, these three kind of deal with, well, the first and the third deal with probability, which we'll study extensively in chapter four, but these are kind of common sense questions. Andrew rolled a die 5 times and got a 6 every time. Well, yeah, it's not possible. Unlikely. It's not impossible. It's possible, but very unlikely. All right, and we'll study this in chapter four. Possible, yeah, it's possible, all right, but the probability, as we'll calculate, is going to be 1/6 to the fifth power. Very small percentage. Number two, if you follow the link in section 2.1 for the birthday problem, we have 23 people. There's a 50% chance that two people have the same birthday. Right? That I mean the same month and same day. It's called a paradox. It doesn't sound like it's true. With 150 people, it's like 99.9%. Called a birthday paradox problem. With 23, it's 50-50. With 150, it's about a sure thing. Lori rolled 3 dice and got a total of 2. Well, on a die, there's 6 sides from 1 all the way to 6. So if you roll it 3 times, the smallest number you're going to get is the number 3. You're not going to get a total of 2. There's no 0 on the die. So pretty common sense question. That's impossible. All right, the smallest number you can get with rolling 3 die would be the number 3, a 1 and a 1, and followed by another 1. Number 4, a sample. As soon as I see the word sample and he's giving me some information about it, I know it's a statistic. A statistic is some numerical information about a sample. He tells you right here, the second word is sample. Number 5, after inspecting all 55,000 kilograms, well, all 55,000 represents a population. If we have numerical information about a population, it's known as a parameter. Recall what I told you before: parameter, population, sample, statistic. Number 6, if you follow this, whenever you see temperature, you know it's the interval level of measurement. If I went through the process, I would say, all right, one sphere has a temperature of 20 degrees. That would be a label. All right, can I put them in order? Well, if one had a temperature of 20 and one had one of 30 and one had one of 50, I could arrange them from lowest to highest. The reason it falls into an interval level because it meets the ordinal level. There is no zero starting point. All right, it doesn't make any sense to say that a sphere whose temperature is 30 degrees is twice as much as 50. There's no zero starting point. Temperature automatically interval level. Salaries is money. Ratio salaries, money always falls into the ratio level. It meets the nominal. It's a label. I can order them. There is a zero. A professor may not be working one semester. He could be making $0. But it makes sense. If one professor makes 30,000 and one makes 60, the one who makes 30 makes half as much, or the one who makes 60 makes 2 times as much. Ratio level. Number 8, here we are back at temperatures, automatically interval level. Ages, ratio level. Here again, I could go up the scale. Someone is 15 years old, that would be a label. You had 3 or 4 people, you could rank them according to age, smallest to largest. A child could not be born yet. It could be a 0, all right? It could be the interval level, and it meets all of that. Then finally, it falls into the ratio level. Someone is 20 years old, they're half as old as someone that's 40, or a person that's 40 is twice as old as someone that's 20. ABC. Well, we could start out with it meets the nominal level. Everything meets the nominal level. Can I order it? Yeah. An A is better than a B, high average. A B is better than a C. It falls, it doesn't meet the interval level because differences are meaningless. Someone could have an A, could be a 98. Someone could have an A and be a 92. So, yeah, I can order them, but differences are meaningless. All right. So it stays into the ordinal level. It doesn't meet the criteria to go to the interval level. ABC is very similar to 1 star, 2 star, 3 star. Good, better, and best. Interval level. I'm sorry, ordinal level of measurement. Convert 7/11s to a equivalent decimal. What'd you calculate? Divide 7 by 11. You'll see it's 0.636. To change to a percentage, you multiply by 100, which necessitates moving the decimal point 2 places to the right. Letter C. Convert 25% to an equivalent fraction in decimal. Well, 25% means 25 over 100. as a fraction 1/4, 25 hundredths, 0.25. Convert 0.368 to an equivalent fraction or a percent. Well, for a percentage, you would move it two places to the right, but there are two answers. Letter A and letter B both have 36.8. There's a neat feature in your calculator. You put in 0.368, you go to the math function, and the very first option is fraction. You choose fraction, it'll take 0.368 and it'll convert it to 46 over 125. Go to the math key, and the very first option is fraction. It'll take any decimal that's either repeats itself or ends a rational, right? It'll take it and take the decimal and change it to a fraction for you. The only other way you would do it is to take 0.368 over 1,000 and reduce it down to the lowest terms, but your calculator will do that for you. Number 14, a lawyer has 40 clients, 10% of whom are businesses. Well, 10%, all right, 1/10, 0.10, 0.1 times 40, that's 4 clients. It's not going to be 38 or 36 or even 6, right? 38, letter A and letter C make no sense. 0.10, 1/10 of 40 is 4. If a test has 130 questions and 33% of them are correct, what's the number of correct answers? Change 33% to 3300s, 0.33, multiply times 130, and you get 43. I mean, look at letter D, negative 17. I mean, come on. It doesn't make any sense. It can't be 83. 33% is like 1/3. 1/3 of 130 is not 83. It certainly is not 60. On a test of 80 questions, you get 76 of them correct. You did pretty darn good. All right, if you get 76% right, you didn't get letter C, you didn't get a grade of 5%. You certainly didn't get 0.95 of 1%. You can't get over 100%. So, it's 76 out of 80, 95%. Or here's another way: take the fraction 76 over 80, change it to a decimal. All right, hit enter. It'll change that fraction to 0.95. 0.95 as a percentage is 95%. But common sense dictates. You don't even have to do all that. You get 76 out of 80. You did pretty good. You get 95%. 17. Identify the sampling used. Random, stratified, systematic, cluster, or convenience. Now remember, I'm not going to give you an answer that is random. There's one here at the very end, and I'll talk about that. Sophomores, juniors, and seniors, all right, those are strata. Now, I'm taking all of those sophomores, juniors, and seniors. I'm taking just some of them. I'm using simple random sampling to select a certain number, stratified sampling. 500 drivers under 30 years old, 500 drivers over 30 years old. Here again, the under 30 and the over represents the strata. I'm not surveying all of them, just some of them, stratified sampling. All right, tax auditor selects every thousandth, systematic, every fifth, every 50th, in this case, every thousandth, classic, systematic sampling. An education researcher randomly selects 48 middle schools. Those are my cluster, and I interview all of them. That's why I highlighted the word all. When you see the word all there, sometimes cluster gets confused with stratified. The key thing is when you survey all of them, you've got cluster sampling. 21 is random, but I won't ask you this. The reason being is that random sampling is part of stratified and it's also part of cluster. This particular answer is random, but on an exam, I'll never give you a question where you have to answer random because random is part of stratified and cluster. All right, so you won't see an answer like letter E, but in this case it is, but not on an exam.